In this lecture, we are going to talk about lateral earth pressure in active condition. So our aim is to estimate the lateral earth pressure under active condition on the back of the wall. The other day we have seen there are three types of pressures. One is at rest, the second one is active, and the third one is passive. In active condition, the backfill soil tries to push the wall away from the soil, as shown in the figure. All the examples that I have shown you, they are all failures by active earth pressure. The analysis procedure is exactly the similar what we have done it for at rest condition. So the first step is to find vertical effective stress. The second is to find lateral stress, and then that is calculated as the coefficient of lateral pressure K multiplied by the vertical effective stress. Point to be noted is that pore water pressure is always treated separately. It acts in all direction and you do not need to multiply pore water pressure by K. Then once you draw these diagrams, then you can calculate the lateral thrust or the force, and that is equal to the area of the lateral pressure diagram, and then that thrust will act through the centroid or the center of gravity of the pressure diagram. So the procedure is exactly similar for all these cases. We have also seen for the active condition, the coefficient of lateral earth pressure or K sub A can be calculated as tan square 45 minus phi over 2, where phi is the angle of internal friction. And once you find out K sub A, then you can calculate the active stress or the active lateral stress by multiplying vertical effective stress by the active coefficient. Now always remember, we are solving a case where C is considered as 0. That is, we are calculating active earth pressure for sand where C is 0. So we are going to see the same example which we solved for at rest condition, and again the soil properties are same. There is a wall which is 8 meters in height. The backfill is sand and it has got phi or the angle of internal friction is equal to 36 degrees. The dry unit weight is 17 kilonewton per meter cube, and gamma saturated or the dry saturated unit weight is 21.81. So let's solve this example.